Today, we're going to learn what knowledge graphs are, what this concept means in the world of machine learning. We're going to also learn about Google's knowledge graph. We're going to talk about a lot of patterns that show us different information about how the knowledge graph is built, how it is updated. And we're also, of course, going to talk about what this means for search. Very exciting. Can't wait to get into it. Hopefully, you're excited about it too. With that, let's start with what knowledge graphs are. Knowledge graphs are structured databases that store information in a graph format to connect facts, entities, and relationships in a meaningful way. There are several key principles of each knowledge graph. Entities are part of it. The entity attributes is another part. The relationships between these entities, organizing principles, and we're also going to add a couple of more concepts as we advance. Keep in mind those. A knowledge graph is essentially an organized representation of real-world entities and their relationships. And it's typically stored in a graph database, which natively stores these relationships between the entities and the entries that we have in this database. Entities in the knowledge graph can represent different things like objects, events, situations, concepts. The relationships between these entities capture the context and meaning of how they are connected. So in terms of usability and applications, the usefulness of knowledge graph lies into the way that it organizes the data, the principles of organization, the data itself and how valuable this data is, how it can be used, and the relationships that the knowledge graph stores. Of course, this makes knowledge graphs very useful for real-time applications, for search and discovery, and for grounding generative AI applications for question and answer capabilities. Because knowledge graphs store data in a very consistent way, this can reduce hallucinations in generative AI and improve its performance overall. When we talk about Google's knowledge graph, we see it everywhere in terms of how Google works nowadays. Whenever you do a Google search, Google automatically will identify some entities if there are any present in your query. And of course, it will use its knowledge graph to see whether there are any connections between the entity that you are searching for or that you're referencing and maybe some other entities that are closely related. And in some queries, you will also see that Google services a knowledge panel, which is just a combination of all of the different things that it knows about a certain entity or a concept and so on. So this is generated with data that is stored within Google's knowledge graph. How do knowledge graphs actually work? Let's hone in on some of the key elements of knowledge graphs. The first one is nodes. Nodes are components of a knowledge graph that denote and store details about entities. And of course, entities can be people, objects, institutions, events, and so on. And each node has one label or several labels to identify the node type or maybe even the attributes of the node. The second element is, of course, the relationship. The relationship is a link between two nodes. They show how the different entities are related to one another. And like nodes, each relationship is going to have a label that will identify what kind of relationship it is. And it may also have one or more different properties. They can also be called edges of the knowledge graph. Another element is the rules, or otherwise the organizing principles of the knowledge graph. Organizing principles are a framework or a schema that organizes the nodes and the relationship according to fundamental concepts essential to the use cases at hand. Unlike other data designs, knowledge graphs can actually very easily integrate multiple organizing principles, and that's why they can store a lot of information, and it makes them a very good choice for organizing a massive database of entities, relationships, and facts, and so on. So on the screen now, you can actually see a simple knowledge graph of an e-commerce example that shows nodes as circles and relationship between them as arrows. The illustration uses color shading to show which nodes and relationships are the instance data and which are the organizing principles. Another concept that is very commonly mentioned when we talk about knowledge graphs is ontologies as well. The ontology is a formal specification of the concepts and the relationships between them for a given subject area. Semantic networks are a common way to represent ontologies. Put simply, the ontologies are a type of organizing principle that can be used in a knowledge graph. While the ontology is a formal framework that defines concepts, categories, and relationships within a specific domain, and that domain can be search, it can be financial institutions, and so on, the knowledge graph is actually the network, interconnected entities, nodes, and relationships that represent the real world data, but they can be based on an ontology. And a purpose of the ontology is to provide a blueprint for organizing and interpreting the data and to enable automated with reasoning, while the knowledge graph itself integrates and connects diverse data sources to facilitate semantic search, advanced queries, and insights discovery. In terms of functionality, the ontology defines the schema and the rules for a certain domain, supporting inference and reasoning over abstract concepts, while the knowledge graph implements the schema to map it to real-world data, enabling visualization, querying, and analytics. The first question that you might be asking is, how can you enrich Google's knowledge graph? Or otherwise, how can you add entities to Google's knowledge graph? So in a patent, they describe that a knowledge panel is triggered when a search query references a known entity, and the search system determines that displaying relevant factual information about the entity would improve the user's search experience. Google first classifies the search query in terms of the general intent, and then if factual information can enhance the user experience, then it will trigger a knowledge panel. The process considers different factors like topicality, click-through rates, and the availability of content to decide whether to show the knowledge panel and how to display it and what information to include in it. So how the process generally works is, first they receive the query, they obtain search results responsive to that query, then they identify entities referenced by the query and choose a specific entity from the first set of entities that is eligible to have a knowledge panel displayed based on how relevant might be to search results. And then they decide whether to display a knowledge panel for the entity with the search results based on the content of the panel and the characteristics of the search results that it has. And the panel includes content from at least 2 different sources. So that is very crucial to know that knowledge panels very rarely include information from just one source. Then the final step is displaying the knowledge panel to the user. What does this mean for SEO? The relevance of the entity to the search query plays a crucial role in determining whether a knowledge panel will be triggered. Focus on how topical and relevant your content is in relation to the queries that you have identified as opportunistic for your business. Another thing to consider are factual entities. Identify which entities are related to facts. So those could be specific people, organization, concepts related to a search query. And that doesn't just mean the entity itself, but also all of the queries that reference this entity. Because as we can see, Google processes the query, it identifies the entity, and then based on that information, it decides whether to show the knowledge panel. Understanding not only the entities, but also the queries that reference that entity can help you to understand when a knowledge panel can be triggered and whether this potentially could impact the click-through rate. Another thing is that we can see from the panel that Google uses content from multiple sources. Knowledge panels display content from multiple sources, such as Wikipedia, the official websites, and other sources that Google considers authoritative in the niche. So what this means is that in order for you to add an entity to the knowledge graph and maybe get a knowledge panel for your brand or for yourself as a personal brand, you need to focus on having a consistent image across multiple different sources that reference you as an entity in a consistent way. Also focus on content distribution across these trusted sources to increase the chances of that content being picked up in those descriptions of brands and people being processed by Google. Knowledge panels are triggered when a search query refers to a recognized and relevant entity. The entity should have consistent content across different sources, and the query should align with the entity's topicality. Both of these aspects are important in order for a knowledge panel to be triggered. And you should also consider another aspect like disambiguation and dominant entity panels. Consider cases where multiple entities might match a query, where a disambiguation panel or a dominant entity panel might be shown that highlights what is the most relevant entity for the search query. So what I mean by this is that maybe there might be 2 John Adamses and one is a poet and another one is an SEO professional. And Google sees that whenever people are searching for that name, most likely people would like to see the poet and not the SEO professional, but Google still recognizes that the SEO professional exists. Another example is London in the UK as a city and London in the US as a city. London has a massive population and is more, well known worldwide and more relevant for people searching from Europe, for instance. Google might use all of these different data points to decide to show the London UK knowledge panel for people searching in Europe. Whereas if someone is in the US and they're searching for the same query, Google will incorporate all of these different data points and show the knowledge panel that is more relevant to that location and that user. We've already discussed how knowledge graphs are used for query refinements and query augmentations. Whenever a search query includes an entity references to distinct queries, Google identifies attributes related to each potential entity that they can surface information for. And these attributes are used to generate augmented search queries, to refine and expand the original search results to provide more comprehensive and organized information, and to possibly also expand and improve the search experience for the user. And of course, this approach leverages the knowledge graph to identify potential query augmentations that reference the same entity or closely related entities to it. This is just one way that traditional keyword-based search is replaced with a more entity-centric understanding, which allows for Google to disambiguate the query and retrieve information in a way that is more useful for the user, incorporating real-world concepts and data. So how can you actually enrich Google's knowledge graph, or otherwise, how can you add entities to it? Google's knowledge graph is regularly updated through something that is referred to as a reconciliation process. Google keeps its knowledge graph accurate, complete, and up to date by finding and adding missing entities and relationships. And what this means essentially is that they add new entities, new circles, if you wish, the nodes, and they add the new relationships between these entities. So how are they related to one another? And here we're going to be introduced to another concept related to knowledge graphs, which is tuples. And a tuple is the relationship between an entity, which is a subject, and a fact about that entity, or a predicate object pair. A basic unit of a knowledge graph can be a tuple, which includes two entities, a subject entity and an object entity, and a relationship between them. So tuples essentially represent real-world facts. Consider something like Maryland is a state in the United States. So this sentence would have a subject, a verb, and an object. But a tuple can also include information like context information, statistics, audit, data about the edges, and so on. So this is what a knowledge graph with tuples might look like. Whenever a tuple exists as an element of a knowledge graph, there will also most likely be attributes related to that tuple that indicates essentially where that fact is coming from, amongst other things as well. It could be what is the language, which user this is important for. It can include a score also for the original source for the tuple. So where did you get the fact from, for instance, and how authoritative is the source that you got this fact from? But that's one way that Google might be working with tuples in their knowledge graph. How are new facts or otherwise tuples added to the knowledge graph? There is a patent that specifically talks and addresses this question and shows us one of the approaches that Google might be using. Consider this scenario. The knowledge graph can sometimes lack information about some entities that it found on web pages, for instance. And what do they mean? But there's no one person or team that manually will go and check and update this information in their knowledge graph. So they have actually found ways to make this approach. So one way is inverse tuples, which means that Google flips facts to find new facts. So in the image here, you can see that if Google discovers a statement in a web, let's say Planet of the Apes was released in 2001, the inverse fact that it will query in its own database is whether 2001 is the release year of Planet of the Apes. And that is one way for it to query across multiple data sources and across its entire index of pages. And when Google finds new reliable information, it then merges it into its existing knowledge graph to fill in the gaps and add additional details. But of course, this process has to be validated across multiple different data sources in order for a fact to be added to the knowledge graph. How does Google find missing information? Google looks at data from different sources and groups them together based on the information that they have shared. If, for instance, it includes multiple sources that mention Maryland, Google is going to cluster them to decide what the fact about Maryland should be. And that will cluster potential tuples by the source, the score associated with the source in terms of authoritativeness, the subject entity type, the entity name, and so on. And within these clusters, Google is also going to amplify the importance of facts that it knows that are certain, like for instance, Maryland is in the USA, to further organize data and distinguish different entities that might hold the same name. So for instance, Maryland is in the USA, but are you referring to the state Maryland or the Maryland University? Google will actually have different type of information recorded in the knowledge graph to actually distinguish between these these two. So how is the knowledge graph actually updated? Google systems identify information that's missing from a collection of data, and it generates its own question and answering service based on the missing information and uses the response from the question to update the data collection that it does. The sources are comparing properties associated with an entity reference from which they have identified missing elements in relation to the entity. What this means is that Google will not consider something to be important or factual or worth adding to the knowledge graph if it's only mentioned in one source. So multiple sources do need to have a reference to this in order for Google to actually add this to their knowledge graph. And it also has to be identified from a collection of sources that are in some ways different from one another and also authoritative. And they all need to reference that entity and contain certain facts that it doesn't have within the knowledge graph in order for that process to be triggered. What this means for SEO, Google detects whenever information is missing or outdated or incorrect in its knowledge graph by analyzing user queries, search behavior. For instance, if they detect that users are frequently searching for information that is not present in their knowledge graph, that will trigger their systems signaling a potential gap. They also have a question answering mechanism to address these gaps where Google will generate specific queries aimed at retrieving the missing information in order to add it to its knowledge graph. And by processing these queries, Google will gather relevant data to update and enrich its database. Google, of course, uses multiple different data sources to do that, including web pages, other structured databases, and user interactions with those web pages in order to extract the information that's accurate and up to date at all times. Another patent actually shows us that Google can actually answer questions by utilizing its knowledge graph as well, of course, as we know. The way that this works is through a two-step machine learning model that is described in this patent, which has an encoder and programmer component. The first part, which is essentially the encoder, refers to building and maintaining the knowledge graph using all of these different processes that we have mentioned in this lesson already. And the second part is actually the programmer model, or otherwise how it answers questions. And we see this implemented in several of the SERP features that aim to provide the zero-click experience and provide the answer directly in the SERP. The user submits a natural language query like, who is Barack Obama married to? The programmer model translates the natural language question into an executable program, which is a set of instructions used to retrieve the information from the knowledge graph. Then the program will query the knowledge graph by navigating all of the different entities and relationships to find the relevant answer. It will search for relationships or parts of the knowledge graph that show the links related to the entity, the node, Barack Obama, that mention something along the lines of is married to, or something related to marriage. And then it will extract that information, present it to the user in a clear and concise manner, some possible additional queries to further encourage users to continue interacting with the SERP, like who Michelle Obama is, whether they have children, and so on. There are several different patterns, and this, as I said, is only scratching the surface, that show that knowledge graphs are also used for personalization of the user experience as well. And that could be in different contexts. One context is via voice search. Another context is in mobile searches. Google uses knowledge graphs as a way to provide personalized responses for people using different devices, searching on Google in different contexts, and also combined with the information that Google has for users, like specifically their search history, browsing history, and so on, they can use the knowledge graph to tailor the responses that they see in the search experience that they have. Another question that you might be asking is which queries trigger knowledge panels? So in two separate patterns, we have the answer for this. Knowledge panels are triggered in queries that are directed to learning, browsing, or discovery, which would give us an indication of some of the intent buckets or intent categories that, we might be expecting to see a knowledge panel. And it's typically provided for queries that have been determined to reference a particular entity, which is very important, like we have already identified and shown why. And that entity could be a concept, it could be a subject, person, place, and so on. So all of the different entities that Google records might be triggering knowledge panels at some point. And here's a few examples of an entity or a location that exists in New York. It could also be triggered for a definition or a concept that is referenced in a what is type query, which we would traditionally categorize as informational, but that expresses a learning need, right? It could also be an entity attribute pair. So the height of the entity empire state building, which is a factual query. It is informational, of course, but it is something that is not exploratory in nature. It is a very zero-click activity that the user is trying to perform. And it does have a single truth answer that Google directly pulls from its knowledge graph in order to provide the knowledge panel that you see. Let's conclude what we learned. Knowledge graphs are powerful tools for representing and organizing information in a structured and interconnected manner. They consist of entities, which are also called nodes, and their relationships between them, which are called edges. Also, organizing principles, or otherwise the rules of the knowledge graphs, and in some cases can also have tuples, which are the facts related to these entities, which all of these combined enable machines to understand the context and connections between data points. Google's knowledge graph plays a crucial role in enhancing search results by providing knowledge panels, refining queries, and enabling a lot more comprehensive information retrieval that is facts-based and not based on just the keywords or the words that you see on the screen. Understanding how Google utilizes knowledge graphs can significantly impact how effective your SEO strategies are. If you focus on topical relevance, factual entities, content from multiple sources, and knowledge panel triggers, you can improve the way that your site and brand are visible in the eyes of users, how they are featured, and you can better understand where your traffic might be missing if you're always going after factual entities that Google already provides a zero-click response for. Google's Knowledge Graph API actually allows us to programmatically access and leverage the knowledge graph for various different applications in semantic keyword research, and that could be things like exploring data recorded for a particular entity, how popular that entity is, or even clustering keywords based on referenced entities within them. With that, as usual, I want to thank you for watching, and I'll see you in the next one.